Hello everyone. Previously, we discussed about ES6 modules, that is import and export keyword along with the default keyword as well, right? So today we'll be discussing about the currying and the along with the currying, we'll also be discussing about functional composition. So basically, what is currying? Currying, currying means in functional programming, it is not related to class. So in functional programming, function, instead of taking multiple arguments at a time, it will take only one argument at a time and returns function, and that function will also take one parameter at a time and returns another function until all the arguments are completed. This process will carry on until all the arguments are completed. So this process we call it as currying. So it is also one of the application of the closures as well, right? So, and what is function composition? Function composition, basically what function composition does is, now we have the multiple functions, right? So it will combine the multiple functions into a single function, where the output of one function will serve as the input of another. So this is what the function composition does. So let's try to understand this one with the simple examples, right? First, let's try to understand the concept of currying. So let me consider function. Let me give multiply here. I'll just take, instead of multiple parameters, I'll just take one parameter, that is a, and I'll just return another function. Nothing but return function of another parameter b. You can consider c as well. I'll just stop with a and b. So here I'll just give return a into b. So let me give here const double equals something like I'll just give multiply 2. Let me consider 2. You can consider any value here. So let me log 2 values here. I'll just give console log of, I have considered double, right? Double of 5. This is one thing. Let me copy the same thing here. So I have to copy that whole line. So I'll just come here. Just give me a second. Here, let me consider 3 and 4. So the output that we need to get is 10 and 12, right? So here this will be 5. 5 into 2 is nothing but this one. 5 into 2 we have to get 10. And this one has to be 3 into 4, nothing but 12. So here, instead of double, this is not the double. So double, if I consider this one, this will consider this one, right? Multiply of 2. I'll just directly take multiply. So the output has to be 4 into 3, 12. Let's run this. So yeah, we are getting the output 10, nothing but 5 into 2, 10. And multiply of 3 into 4 will be 4 into 3, 12. We are getting the correct output. So this is about currying. So what happened? I'll just tell again. So here, function multiply of a. This one takes one argument and returns the new function here. You can clearly see. And this function also takes only one parameter, that is b, right? So basically this return function b uses the value of a from the closure, this one. So as I have said, this is also one of the application of the closure. Currying is also one of the applications of the closure. Here, the return function b uses the value of a from the closure. So I hope this is clear. This one here, let's come here. Const double of this one 5 we have given here, right? This one basically we're multiplying 5 by 2, and multiply of 3 into 4, we are just multiplying 4 into 3. So the output has to be 10 and 12. We have got the correct output, right? So this is it for the closures. So next, let's discuss about the, let's consider the example for the functional composition. So just give me a second here. So I'll just take const add equals. Let me consider the parameter x here. I'll just give x plus 2. Add, I'll just take multiply. Let me consider the parameter x itself. Here, let me give x into 3 or x into 2. Anything is fine. I'll just consider x into 3 here. So let me give const compose the parameters. I'll just consider f and x. I have already considered, right? I'll just consider f and g. X, this one has to be f of g of x, right? So next what I'll do, I'll just consider the variable name result. I just give here compose of, let me consider add and multiply, or multiply and add. So I'll just give multiply and add. So whenever I log, let me log here result of something 3, or I'll just consider 4 here. So this one has to be, whenever I consider 4, due to this one, compose of multiply add this one. So here we have to get 4 here. First it will come here. 4 plus 2 is 6, and finally 6 into 3 is nothing but 18. So we have to get the output 18, right, according to this one. So let's see. Let me run the code here. So yeah, we are getting the correct output. So what we are doing here, first add. So this function, this one adds 2 to the input. We can see here, whatever input that we gave, this adds 2 to the input, nothing but x plus 2. So the second one, this one multiplies the input by 3. Here we can clearly see x into 3 we have given, right? So let's come here, compose. What the compose is doing here, it creates a new function that applies g to x, right? So this applies g to x, and finally f to the result. So that's what the compose is doing here. So result of 4, when I log result of 4, so what computation is going on here? 4 plus 2 into 3 is going on, right? 4 plus 2 is nothing but 6. 6 into 3 will be 18. So that's what the output that we got. So I hope the functional composition, as well as the this one, carrying, both are clear. So this is it. Next we will be discussing about the event delegation, right? So for now, this is it. Thanks for watching, guys.